morning, I'm Joe. Today I'm going to cover Python lists, tuples, sets, and dictionaries. Now the list is the most widely used data structure in Python. It's very general purpose, similar to an array in Java, and it covers most of what you would need. But tuples, sets, and dictionaries have some advantages in specific areas and are very, very useful data structures. So the list is a sequence type, it's sortable. The tuple is immutable, which means it can't change, add, or remove items in a tuple once it's been created. So it's useful for fixed data. And tuple is also a sequence type, which we'll explain in a second. The set, you can store non-duplicate items, so it's good for storing unique items in a set. And it's also very good for doing mathematical comparisons to sets. Union, intersect, those kinds of set operations. Dictionaries contain key value pairs. It's like an associative array, similar to a Java hash map. And both sets and dictionaries are unordered, which means they're not sortable and they're in random order. And one amazing thing about these data structures in Python is that they can hold any data type. So they could hold integers, floating point values, strings, or other object types, and even other lists, tuples, sets, and dictionaries. And the data types don't have to be homogeneous. So you can mix and match data types within a single list, or within a set, or within a dictionary. Now, sequences include lists, tuples, and also strings. There are a bunch of different functions that are applicable to all three of these data types, and we're going to go into them in detail. So indexing, you can access any item in the sequence instantly using its index. If you have 1,000,000 items in your list and you want to access an item instantly, you can do that if you know its index. So a string is a sequence of letters. Let's say we want to access one of the items in the word frog. We can say print x of 3 using the square brackets for the 3, and that gives us the third index. Starting from index 0 for f, the g is going to be index 3. And in our list, if we say we want item with index 1, that's going to give us cow, the second item in the list. Slicing allows us to slice out substrings and sublists and subtuples using indexes, and the syntax is using square brackets, start, end plus 1, and step, and these are all optional. I'll cover some examples that explain that. And these are applicable to strings, tuples, and lists, but in this example I'm just going to use the word computer, which is a string. So let's say we have x from 1 to 4 using a colon, and this will return to us items 1 to 3, which is OMP. If we want to slice items 1 to 6, this actually cuts off at 5, and it'll give us every other item since we have a step of 2 here. So items 1, 3, and 5, OPT. And X with items 3 to basically no end, right? We didn't put an item after the colon, so that's going to give us 3 onward, so PUTER. If we don't put anything before the colon, then it starts at 0. So this will give us items 1 through 4, or rather 0 through 4. And if we want to use negative numbers, here we can use -1, which will give us the last item in a list or a sequence. So x of -3 colon nothing is going to give us the last 3 items in a sequence. And then if we have x colon -2, will give us everything except the last 2 items in the sequence. Adding and concatenating we can do using the plus symbol. So we can combine 2 sequences of the same type only. So if we have 2 strings that we want to combine, we can use a plus sign to add them together. And if we have 2 lists we want to merge together, we can use the plus sign, and will give us 1 list with 3 items in it. Multiplying, we can use the star sign to multiply sequences, again of the same type. So if we have a bug, it will multiply the word bug 3 times and give us bug, bug, bug. Or if we have a list with an 8 and a 5 in it, we want to multiply that by 3, it will give us 8, 5, 3 times in our list. Checking membership tests whether or not an item is in or not in a sequence, using keywords in and not in. So it's very simple to use. So if we have x equals bug and we want to print u in x, it will print true if u is actually in x, and it'll print false if it's not. So in our list, pig, cow, horse, print cow not in x. Will print true if cow is not in x. However, cow is in x, so it prints false. So that's checking membership using the in and not in keywords. Iterating, we can iterate through the items in a sequence using for loop. So if we have list of integers in x, we can say for item or any variable name in x print or whatever we want to do to that variable name. It returns to us 1 list item at a time, each loop iteration. And if we need both the index and the item, we can use the enumerate function. So we say for index and item. We basically need 2 variable names here. The first one is going to be the index. Second is going to be the value or the item in enumerate x. And then we can do, inside this for loop, we can do whatever we want with those two variables. Here I just have a print statement that prints the index followed by the value. Number of items, we'll count the number of items in a sequence. And we do that using the len function, which is short for length. And we can do the same thing in a list. Prints the length of a list, 3 items in this list. Minimum finds the minimum number lexicographically, which means alpha numerically. But this only works when all of the items in the list are either alpha or numeric. You can mix and match integers and floating point values, but you cannot have both strings and integers. So if x equals bug, we want to find the minimum is b. If we have a list of 3 strings, we're going to find the lowest one, which is c, cow. So it prints cow. Maximum is going to find the maximum item in a sequence, again lexicographically, and they have to be all the same type, either numeric or string type. So if we take the maximum of bug, we get u, and if we take the maximum of pig, cow, and horse, we're going to get pig because that comes last alphabetically. Sum, we can find the sum of the items in a sequence if they're numeric type. So 5, 7 in bug is going to give us an error because bug is not a numeric type. But if we take the sum of 2, 5, 8, and 12, it's going to print 27. Or if we want to do a slice, we can say, hey, I just want the sum of the last 2 items of x, and this here will print 20. We can sort the items of the list. This sorted function actually returns a new list without changing the original list. It returns a new list in sorted order. So bug will return the letters of bug in a list in sorted order, B, G, U. And our list pig, cow, horse, if we call sorted of x, it's going to return cow, horse, pig. And mind you, the original x is still unchanged. Count of item returns the count of a specific item in the sequence. So here we're looking for the count, x.count of p will tell us there are 2 p's in hippo. And x.count of cow will tell us how many times the word cow appears in our list x. If we want to find the index of an item, the index function actually returns the index of the first occurrence of an item. So if the item is in the list or sequence multiple times, it returns the index of the first occurrence. So here the h is 0, the I is 1, the first p is 2. So x.index of p is going to return 2. And here we find the first cow, which has an index of 1. Unpacking, if we want to assign all the items in a sequence to a set of variables, we can say a, b, c equals x. And then all of the strings in x will be assigned in order to the variables here on the left. So pig assigned to a, cow assigned to b, and horse assigned to c. But this only works if the number of variables exactly matches the length of your list. So here we have 3 items, we must have 3 variables. So that covers general functions for sequence types. Now let's talk about specific list functions. So there are a few different ways to create lists. We can say x equals list parentheses. We can say x equals in square brackets whatever list items we want to add to populate the list. And again, we can mix and match data types. So we have here some strings, integers, floating points. And we can say x equals list and then in parentheses a tuple, and we'll get a list from the items in the tuple. There's a really cool function called list comprehension. So we can create a new list using what is returned by the for loop for m in range 8. So m in range 8 returns the values 0 through 7, and here we're saying we'll just take those values, m. So the resulting list is 0 through 7. Here we have a for loop that says z in range 10 if z is greater than 4. So in other words, items 4 through 9. But we said, hey look, instead of adding the item itself, z, to our list, we want to add z squared. So it's going to take 5 through 9, and it's going to square each one of them and add it to the list. So we get 25, 36, 49, 64, 81. So list comprehensions, you can have fairly complex functions inside of the square brackets to create and populate a new list with whatever values you want. Delete, we can delete an item from a list, or we can delete a complete list. The item we would delete using the index, or we can delete the entire list. Append, we can append an item to the end of a list using the .append function. Extend, we can combine 2 lists. This is very similar to the plus function that we already showed. X.extend y is going to combine both x and y together into list x. Insert allows us to insert an item into a certain index position. So here we want to insert a 7 into position 1. It will scoot the rest of the items to the right and put the 7 into the list. And here we're going to insert a sublist or an embedded list with letters A and M into position 1, which is going to scoot all the rest of the items to the right and pop our sublist right in here. The pop function pops the last item off of the list and returns it. So if we want to, let's say, print an item as we pop it off the list, we can say print x.pop, and it will print the last item on the list. And the new list will have one less item in it. Remove is going to remove a specific instance of an item. So if we want to remove a 3 from this list, we can put x.remove 3, and it will remove the first 3 that it finds. Not every 3, just the first 3. So you can see here the first 3 is gone. And reverse reverses the current order of the list. So the number that is first will become the last, the number that is last is going to become first, and so on. Sort will actually do an in-place sort. So the new list you get back, our list X here, is going to become a sorted list. So unlike the sorted function, sort is an in-place sort. So it actually changes the order of the items in list X. Now let's talk about tuples. So tuples support all of the operations for sequences, but tuples are immutable. So member objects inside a tuple may be mutable. For example, you may have a list inside of a tuple, could be one of the items in your tuple. That list is still mutable. You can still change and add and delete items from the list, but you cannot delete the list itself from your tuple. So it's a little confusing. I'm going to show some examples in a second. If the contents of a list shouldn't be changed, then you can use a tuple. That's what tuples are used for. It's useful when you have a constant set of values that are not going to be changed that you want to use throughout your program. And tuples are more efficient than lists due to how Python implements them. So how do you construct a tuple? Well, a new tuple with no values in it is going to just be created using the parentheses. And we can say x equals 1, 2, 3 if we want to create a tuple with values 1, 2, and 3 in it. And you don't even need the parentheses actually. The parentheses are optional. If you want to create a single item tuple, you still have to put a comma after that item. Otherwise, it would just assign x equals integer value 2, and x would be an integer, not a tuple. So the comma tells it, hey, this is a tuple, but it's a single item tuple. And we can create a tuple from all the members of a list, just using the tuple function. So tuples are immutable, as I said. If we try to delete an item from a tuple or change the value of an item in a tuple, we're going to get an error. But if we have, let's say, a list inside of a tuple, here we have a tuple called x, and our first item is a list with 1 and 2 in it, and our second item is an integer 3. So we can't change that 3. That's immutable. However, we can change the list. Here we're going to delete the first item in the list, which is 2, the item in index 1. So our new tuple has a list with just the 1 in it and integer 3. So we can change the list. The list itself is mutable, but the tuple is not. We still have to keep the list in this position. Let's talk about sets now. So there are some constructors. How do we create a new set? We use the curly braces if we want to populate a set with values. And we can create a new empty set using set with parentheses. And we can create a set from a list by calling the set function in parentheses the name of the list. When we do this though, it strips out all the duplicates from our list and returns only unique values to the set. And then we also have, similar to the list comprehension, a set comprehension. So we can use a for loop, if statements, and whatever functions we want to do on those x values. X is probably a bad choice of variables here since we're using x for the set name, but we can use the list comprehension to put values into our set. And sets are unordered, so as we populate the set, the items are going to be in random order. So some basic set operations. We can add an item to set x by using x.addItem, remove an item from set x using x.removeItem, get length of set x using the len function. We can check membership in x by simply saying item in x or item not in x. That's going to return a Boolean true or false. We can pop a random item from set x using the pop function. We don't know which item is going to be popped. It's arbitrarily selected. And we can delete items from set X by saying x.clear. We'll completely empty our set. Some of the standard mathematical functions for sets are very useful. We can find the intersection of two sets using the ampersand function. And we can find the union of two sets using the vertical bar. Symmetric difference or exclusive OR. In other words, items that are in set 1 but not in set 2, or in set 2 and not in set 1, using the up arrow. The difference, which means items that are in set 1 but not in set 2, we just take set 1 minus set 2. And subset and superset basically returns a Boolean value. Does set 2 contain set 1? Or does set 1 contain set 2 for superset question? So those are some of the set operations. Now let's take a look at dictionaries. So a dictionary, again, is a key value pair. And you can see three different ways here to create a dictionary. You can use curly braces with the key first. In this case, I chose to use strings for a key and floating point values for my value. And they're separated by a colon. So this is the most standard way to create a dictionary. You can also call the dictionary function to create a dictionary by placing comma-separated tuples inside of a set. And you can also say key equals value, comma-separated, and call dictionary on that. So there's three different ways to create a dictionary. I find the first one is more widely used and more standard, but they all three work. So some basic dictionary operations. You can add or change an item in dictionary X by saying X key is equal to value. If this key is already existing in the dictionary, then it will change the value to this. If the key doesn't exist in the dictionary, it will add this key value pair to the dictionary. Remove item from dictionary X, delete X, and then the key. Get the length of a dictionary using the len function. Check membership in X, item in X, or item not in X. This only looks in the keys. It does not compare to values. So if we want to look through values, I'll show you a way on the next slide to do that. Delete all items from dictionary X. We can say x.clear, and delete the entire dictionary X, delete X, del X. So how do we access the keys and values in a dictionary? We can say x.keys. It will return a list of the keys in X. x.values returns a list of values in X. And x.items returns a list of key value tuple pairs in X. So if we want to check membership in values of X, we can say item in x.values. And this will test the membership in X and return a Boolean. Iterating a dictionary, we can use for loops. For variable in X, print variable, right? So we say key, we used the word key for our variable. We can print our key. And then if we want access to the value as well, we say X and then key in square brackets. And we can get both the key and the value this way by iterating. However, if we want to do a lot of operations or use the value quite frequently inside of our for loop, we could use items instead. So we can get two separate variables for the key and the value by saying for k, v in x.item. Items is going to return both a key and a value and assign them to variables k and v in this case. So when we print k and v, we print out each key and each value for the entire dictionary. That wraps up my video on Python lists, tuples, sets, and dictionaries. I hope you enjoyed the video. Please click the like button at the bottom. I'm Joe James. Thanks for watching.